Hello there. Let's calculate Pearson's correlation coefficient, aka the real correlation coefficient. Get an idea of what's going on, I'm going to plot the points again. Axes go by 1 on the x's, 10 on the y's. So again, just eyeballing it, it looks like a pretty tight oval, and so we should have a strong positive correlation, and we're just going to go through the process of verifying our intuition. Okay, write down your coordinates, x's and y's. And those are, of course, in list 1, list 2. Now, it occurs to me I should have put this on it. I'm not expecting you to memorize Pearson's formula that will be given to you, but you do need to know how to use it. So let's put the formula down here so we have something to refer to. Okay, sorry for not putting that in earlier. One of the things that we're going to need is this x bar. That is the mean of the x's. So here are my x's. I need to add them up and divide by how many there are. Okay, and I have to do the same thing for the y's. And this point, 5.661.2, is the centroid, the center of mass. I'm marking on the graph there with purple. And you can imagine axes coming straight up from it and straight across. And that sort of divides my data into the upper right. This is effectively quadrant 1. And there's nothing in quadrant 2. And down here in quadrant 3, I have some more data points. And there's nothing in 4. So the fact that my data points are only in quadrants 1 and 3 means that I'm going to have a strong correlation. This is the picture beside the fact we're concentrating on the table. This section here has to be the first part, x minus x bar. So the x's, remember, are in list 1. So this is going to be list 1 minus x bar, which is 5.6. Type that into your calculator. So what's being counted here, this negative 4.6, that's saying that this point here, the 127, it is back along this axis. It is 4.6 below where that centroid is, horizontally. It's back 4.6. And my next column for the y's, that's going to tell me how far below that centroid it's going to be. Define list 4 as list 2 minus 61.2. That's your y's minus your y bar. So, just to pick on this first point again, 1, 27, it is horizontally 4.6 below where that centroid is, and vertically it is 34.2 below where that centroid is. Our next column, we need to actually multiply these numbers together, x minus x bar and y minus y bar. So we're going to take these two numbers and multiply them together. The number in list 3 times the number in list 4. And all of these numbers are positive because I was only doing negative times negative is positive, negative times negative is positive, positive times positive, those are all positive. My data points were all in this upper right section, the new quadrant 1, and the lower left, the new quadrant 3. There were nothing in these two. If there were points in these sections, you would have negative numbers in here. Effectively, what this is counting, this 157.32, let's see, let's highlight that. This is referring back to that point, and it's back 4.6, down 34.2. And that 157.32 is the area of that rectangle. And the 90.72, this one's going to overlap, this is the area of that rectangle. So I keep winding getting more and more areas of these rectangles. Now, if there were points in these quadrants, they would have negative areas that would cancel. Oh, morphine. Back to business. Summation, sigma, means that we have to add them up. Sum that list 5. Okay, so you get that from going to second stat, the list, over to math, sum it up. And keep in mind this 428.4, that's what this numerator up is here is, the sigma stuff. Now down below, n, that's always the number of terms. We had 5s. And this SX and SY, those are standard deviations, and I can get that from the same place, going over to math, or stat, math, standard deviation. Remember, your x's are in list 1, and that number kind of keeps on going, and the y's are in list 2. Okay, these are all the components I need. I'm going to give myself a bit of space here, and start writing in that formula. Numerator, denominator, 5 objects, that's the n, standard deviation of the x's, times the standard deviation of the y's. Okay, got a big expression, type it in. Okay, that keeps going. We'll round to, I like 3, but standard practice seems to be 2, so we'll round to 2 decimal places. And just as expected, this is a strong, very strong positive correlation. Yeah. And we can double check all of that in our calculator. I'm going to want to see this table, the construction of this table, these entries, and setting up the formula. And you can always have your diagnostics turned on and go and double check that the number that you spit out actually is the one produced by those original data points. Character and scholarship for life.